In previous session of parallel programming, we have covered various vectorization techniques and what are the programming styles the user need to follow in order to implement parallelism. In today's session of parallel programming, we'll be moving on to the next topic, which is basics of MPI program. MPI here stands for Message Passing Interface. Why we actually require this message passing interface? Since we are implementing parallelism, here I'm taking an example of a CPU, which is a dual core processor. So as you all know, dual core processor, here I have a core 1 and core 2, and these cores are nothing but your processing elements which have the capability of performing any operation. Now, if you want an operation to be performed, one process is being assigned to one core, the other process is being assigned to other core. So process 0 to core 1 and process 1 to core 2. And in order to execute this process 0 or process 1, though the core has its own individual memory, sometimes core 1 may require the data present in core 2, and similarly core 2 may require the data present in core 1. So in that case, there should be a sharing of information from one core to the other core. That is the reason we go for implementing this parallelism by means of message passing interface. The basic thing when you go for using your message passing interfaces, your communication world. So here communication world here is nothing but the set of process. So this is your P0, P1, P2, P3 and P4. So first of all, you need to identify how many process are being involved in this communication world, and each of these process will be given an id. So process 0 is given an id 0, process 1 is given an id 1, process 2 is given an id 2, and process 3 is given an id 3, process 4 an id 4. And this process ids we call it as a rank. So each process will be identified by an id that is nothing but your rank. So communication world is nothing but the collection of process, how many process are actually involved in the communication, and in order to designate each of the process differently, each process will be given an ID which we even call it as a rank. And that particular rank will range from an integer value 0 to n minus 1. What is this n? N here is nothing but number of process. So if I have 5 process, the value of your rank or the process ID will range from 0 to 4, where n is equal to 5, meaning that I have 5 process. When you want to perform this MPI program, the basic functions that are required here is nothing but MPI communication rank. These are all predefined functions which are present in your MPI.h. So we need to go for including this. What is the purpose of this particular rank? It takes two arguments. One is your communication word. As I told you, this will designate. So, or else you can even call it as a communicator. Communication word, you can even call it as a communicator, which will help us to have the communication between the process. And in place of the communicator, the default identifier we'll be using is MPI underscore communication world. And the next argument we have here is ampersand of rank. If I am passing an ampersand, it is nothing but the address of the variable rank. So this particular function communication rank will identify the number of process present in the communicator, and each of the process will be given a rank. So the rank of each process will be stored in the address specified by your rank. Similarly, if you want to know what is the size of your communication size, because this communicator or the number of process will not be creating it manually, right? So you want to know the number of process that are being involved. So MPI communication size will take the same communicator as a first argument and ampersand size. This will contain the number of process that are being present in your communicator world after executing this function. In order to either know the rank of the process or in order to know the size of the process, we need to actually set up our MPI message passing interface environment. So the first function that is to be used is nothing but MPI init, which stands for initialization, and it takes two command line arguments. One is your argument vector, the other is your argument counter and the argument vector. And after you finish performing your operation, the last function which is to be included here is nothing but MPI finalize. This will tell the system that you are done with your MPI functions. So at the starting, I need to include MPI init, which is for initialization, and MPI finalize, which will indicate that you have finished doing your functions. So when you see the basic structure of your MPI program, the first thing we need to go for using is MPI include. So here I need to go for including MPI.h, which is the header file required for your corresponding functions. You can even declare all your local variables which are required for performing your functions. Then you start initializing your MPI environment where the messages are being passed from one function to the other function, and after that you can call any of your functions. So here the basic thing is you need to call your init function, and here you can go for either using your communication rank to know the rank of each process, or you can even go for including your size. And finally, after performing these operations, you have to go for saying to the system that you have done with your MPI functionality. So you can even go for finalize. So this is a basic structure which is to be used for performing MPI communication or MPI program between the process. Here, we'll just go through a sample example. This is a normal C program with an additional header files that are to be included. So as you all know the need of stdio.h, since I am using MPI functions, it is mpi.h. And here we are going for command line arguments because I need to specify the values. So MPI init will take two arguments. One is your argument counter, the other is your argument vector. And int rank size will specify, these are the two variables. One will have your rank value, the other will have your size. When you go for MPI communication rank, the first default communicator will be used as MPI communication world, and this is an address where the rank is to be stored after executing your function. And this is MPI communication size, MPI communication world ampersand size. So it will give you the total number of processes present in the communicator. And when you want to actually print what is the value of your rank and the size, you can just write any text of your choice, and in place of here, if you want to know the rank, you can just run it as rank, and here it is nothing but the size, the number of process. Finally, we go for initializing, ending it up with MPI finalize, indicating that we are done with the procedure of MPI environment. And as you all know, there is a return type here, it's return 0. So this is a normal and a simple basic MPI program. You can just run it in an online editor, or you can just go for using your Visual Studio, where you can specify the number of process and the output of the program will be visible to you. So if you want to even perform some operation, we even required some data types for it. So what are the data types that are required here? MPI char, MPI char for storing your character variables, MPI short, MPI underscore init. You try it. These are all the data types which are generally used. So when I compare just with your seat data types, instead of signed char here, I'll be using MPI char. Signed short int, it is MPI short. By default, if I don't specify any keyword after char or the short, it is nothing but your int. MPI int. Signed long int is MPI long. So these are all MPI unsigned short. It is nothing but unsigned short int. MPI unsigned int, MPI unsigned long, MPI float, MPI double, MPI long double, MPI byte, and MPI packed. So these are the different types of data types that can be used when you want to perform some numerical calculations while sending the data from core 1 to core 2. So in this session, we have seen how to write a basic MPI program. Coming to the execution process of it, we'll be covering it in the next class.